I'm about 3 minutes after my start time. I think we have enough people here so I can get started, so I'm going to go ahead and do so. Welcome to my session, Building Custom GitHub Actions with Docker. Before we get started, I want to give a big shout out to the sponsors of the conference, Cloudflare and Unspecified. Without them, obviously, this wouldn't be possible, so huge shout out and thanks to them. And also, that will also be hosted in Wisconsin this coming summer, so hopefully you can make it to that as well. It's another fantastic Kalahari resort. So here's the agenda for what we're going to talk about today. I have a lot of ground to cover, so I'm going to talk kind of fast. If you have any questions, hopefully we'll have some time at the end of the talk so I can answer them if I know the answer. We're going to start with introduction to actions. I know that in the prerequisites for this talk, I had said you should probably have a basic understanding of actions, but I really kind of want to lay the groundwork for everybody so we're all on the same page when talking about these concepts. We're going to talk about what makes an action, followed by how to build them with Docker. I have a small demo on how to build a Docker action with Go. We're going to talk about security and access, so you know how to use Docker or GitHub Actions within your organization in a private manner and how to access the repository securely. And then I've got some concluding tips once everything is said and done. Before we get started, that's me. I'm Brian Morrison. That's what AI thinks I should look like, and I like the colorful background in this picture, so I decided to roll with it. By trade, I am a full stack developer, so I like hammering away on code and building cool and interesting things. It's what I've done for most of my life. Been doing it professionally for about 15, and before that, back in the days of MySpace, I used to love to tweak my profile with HTML and CSS. By day, I am a developer educator at a company called PlanetScale, which is a MySQL platform that's built for horizontal scalability and developer experience. As my role as a developer educator at PlanetScale means I do a lot of educating, obviously. So I tell people about the product, but I also sometimes stumble into these weird off-the-wall projects that no one else has taken on and I get inspired to do. That is how I got inspired for this talk. I built the first set of GitHub Actions for PlanetScale that we published. So they're going to be a big part of the talk. We're going to go over some of the examples and things that I built along the way. Before that even, I was a lead backend developer for a telematics company, and then before that even, I was a senior systems engineer working in things like Cisco, VMware, servers, all that real tech nerdy stuff. That picture on the bottom left there is actually in my former house basement, so I'm literally that level of nerd when it comes to backend stuff. I just say all that because this is the world that I like to live in. Outside of all the career stuff, I have a wonderful wife who's chasing around my 3 wild boys so I can be here with you lovely people, and we live on a small farm in Kentucky at the moment. So if you've been working around enterprise software as much as I have, you will know that I go to any enterprise software feature page, and they will say some businessy mumbo-jumbo lingo toss out you like synergy and ROI and KPIs and all that fun stuff. Important, but sometimes it makes it hard to make sense. So I saw this as an opportunity to poke fun at GitHub Actions, and to my surprise, the description on the website is actually pretty straightforward. Just reading this off, automate your workflow from idea to production. GitHub Actions makes it easy to automate all your software workflows, et cetera, et cetera. So GitHub Actions is essentially, in my mind, the way I think of it, is a glorified task runner. You feed it a list of tasks you want it to do, it'll execute them in the order you give it to them. All right, so a couple use cases for actions is one of the most obvious ones is software testing. At least one of the most common ones, I guess, is software. Obvious is probably not the right word to use for it. You can define your unit tests, put them inside of an actions workflow. They'll execute them and report back to you, tell you whether or not your software is working correctly or not. Releasing new builds is another very common one. I actually gave a talk at that Wisconsin last year about how I use GitHub Actions to build artifacts and push them up into AWS. So this is another common use case. Schedule jobs, something I think is a little bit less known, is GitHub executes things based off of triggers. One of the triggers that you can assign to a workflow is a cron job trigger. It's not the most accurate timing in the world, but if you need some low priority things to execute on a fairly regular basis, you can do that. And then last example I have here is project automation. Also on the whole concept of triggers, you can actually execute workflows based on things like issues created or issue status updated, things along that line, so you can automate some of your project management if you use GitHub to manage projects. So we're going to move on to terminology. First one is actions. Pretty obvious. This is kind of the main thing we're talking about here. That's the logo for the GitHub Actions platform. If you talk about GitHub Actions, sometimes you could be talking about the entire platform as a whole, the feature of GitHub that allows you to do all these cool and wonderful things. Next one's actions. No, that's not a typo. Actions seems to be a very overloaded term when you start doing research into this whole thing about GitHub Actions. So you can think of GitHub Actions as the overall ecosystem. You can think about GitHub Actions in the way that I think they're officially meant to be used, which are these shareable, reusable steps that are defined inside of repositories. Or if you dig into other people's content, sometimes they will refer to this thing as an action. This is a workflow. This workflow specifically is what I created as an example for the PlanetScale GitHub Actions. What this workflow will do is when you create a branch inside of a repository, it creates a one-to-one branch inside of PlanetScale, which is kind of one of the big feature sets of PlanetScale. And it will also create a password connection string for that separate branch. Diving in here a little bit, we're going to step through what one of these workflows looks like. So I'm skipping over name because that's pretty self-explanatory. It's the name of the workflow. Trigger, as I mentioned earlier, trigger is the thing that triggers your workflow to execute. This could be things like creating a branch, deleting a branch. You can filter down to individual branches or using like blob syntax in order to define the sub-branches of things you want to execute them on. There's all sorts of different ways that you can kick these things off. Next up is a job. That's kind of like the first, I guess you can think of as the compute side of things. Jobs are collections of steps that are executed sequentially, one by one from top to bottom, and you can have more than one job on a given workflow. By default, they will execute in parallel, but you can also define whether or not you want to chain them together by making them dependent on one another. Moving in from there, the next keyword I want to call out is this runs on. Runs on, well, I guess backing up a sec, when a job executes, it executes on a virtual machine, either in GitHub's backend infrastructure, or optionally, if you wanted to install the agent on machines that you own, you can execute these jobs on your own machines. Right here, I have defined that this workflow will run on the latest version of Ubuntu that GitHub supports. And then finally, the thing I want to call out in this workflow for the time being is the almighty step, which is where we're going to be spending a lot of our time today, because we're learning how to create actions, which in turn will be used as steps. So we're going to dive into this one a little bit farther. Again, skipping over name because we don't, again, self-explanatory. We're going to start with uses. Now, this is where things get really, really cool. GitHub Actions reference actually can be done in one of two ways. They can either be inline scripts that you can write and run right inside of your workflow here, or they can call other repositories, the source code in other repositories, pull them in and execute them. In this case, for this step, the action we're using is PlanetScale/create branch action, and we're using the V1 of that. Going through that one more time, PlanetScale is the organization that owns the code. This can also be a username if somebody publishes a public action on their own account. Create branch action is the name of the repository, and at V1 is the tag of V1 that we've assigned it. It's a git ref essentially. Moving on from there, we have ID. You can chain the inputs and outputs from different actions to each other to pass data along your chain. You need to assign an ID to an action in order to be able to do that, because the workflow itself needs a way, or the job itself needs a way to reference previous steps to pull that data out of. Our with section here defines parameters that are going to be passed into the code. So when this action executes, we're going to pass in an org name of my org, a database name of recipes.db, a branch name of the output of a previous step, and we are passing in the value of main for the parameter of from. If this doesn't make a lot of sense, I have practical examples to clarify all of this. And the final piece here I want to call out is you can set environment variables on your branch itself. So if you have secret data or secret information that you want to pass down into the step that's being executed, this is the way you would do so. You can actually set environment variables on multiple levels, though. Right here, I have the example of it being passed in as a step, but you can also assign it to a job, or you can assign it to the entire workflow. So every single job and step within that whole workflow has access to that secret information. All right, let's talk about ways to build custom actions. Now, there are technically 3 ways to build custom actions, but me and the way that I work, meaning I prepped most of this in the last week, didn't realize there was a third called a composite action. We're going to pretend that doesn't exist for the sake of this talk, okay? So there's JavaScript and Docker. And as you can imagine from the name of this talk, we're going to lean really heavy into the Docker side of things. But I at least wanted to throw this out there as an option for JavaScript developers in the audience so they know that they can do this. There are pros and cons of both approaches. JavaScript technically does run faster. And the reason why these steps run faster is because each step that runs as a Docker action actually pulls in the source for that and has to build the container, build the image to run the container on the underlying operating system. So JavaScript doesn't need to do that, therefore it does run quite a bit faster, especially if you have a lot of steps that are chained together. The downside is you can't build an action in the same way that you would expect to build something like a JavaScript project, where you have something like index.js and a bunch of NPM packages that you're bringing in and chaining together. I'm a little loose on this, so take this with a grain of salt, but my understanding is you have to essentially transpile all of your JavaScript into a single file so GitHub will understand it and be able to execute it without having to reach out and grab in external dependencies. That is a restriction that Docker doesn't have. Because you can basically use any language and pull in any dependencies you want when you're building your image, you can essentially write Docker actions in any language with any dependencies you want, which in my mind is kind of a big benefit. I don't have to understand essentially how to use the JavaScript side of things. I can build actions in Go, which I'll show here. I could build them in Ruby. I can even use JavaScript with NPM packages and put it inside of a Docker image to be run. All right, so let's look at what makes an action an action. Like I said, the repositories, how are they different than normal repositories? There's not a whole lot different. Obviously, it is a repository where all the source code is held. But there's a very special file inside of this repository called action.yaml. And when GitHub detects that an action.yaml file is in there and constructed in the specific way that it needs to understand it, it knows that that repository holds an action. Stepping through this YAML, hey, I actually included name in this one, look at that. So the name of this is create database branch, again, going along with the whole planet scale thing because this was the inspiration for this talk. We have a name and a description. These are published out into the GitHub Actions marketplace, so that's important so people who are looking for actions have an understanding of what an action does before they start diving into it. We have branding, which is entirely optional, but for the same purpose, it differentiates it from other actions in the marketplace, so this way it looks a little bit different. Next, we'll move on to inputs. I had mentioned earlier that the with section of the actual workflow lets you pass in parameters into your actions. This is how you can define those parameters. So just stepping through at the top one of this, which is database name. Database name is that key that we saw earlier where we can pass in a value. It has a description, which is used inside of the GitHub code editor in order for it to have some kind of IntelliSense to help you along with what you're doing, if that's the way you want to do it. But of course, since these are just YAML files, you can write them in VS Code or tmux with Vim or whatever we're using out there. You can also specify whether or not these are required or not. If you specify an input as required and you don't provide it in the step, GitHub won't even try and run it. It'll just bomb out right away. The thing to understand about inputs is it doesn't really matter how many you have defined here. It will pass all of them through as strings. Even if you don't provide a value, it will pass them through as empty strings. So when you're writing your code to build your actions, that's something to definitely keep in mind and account for. Now we're going to move down a little bit into this run section. So runs basically defines how we want to build and run the action. In this case, we're using Docker. That would be, in another world, that would be JavaScript or the pretend composite we don't want to think exists right now. Image is Docker file. That means we're looking at the Docker file we have defined inside of our repository in order to build the image. But you can also use external images. So if you have an image that's published on a registry somewhere that you want to pull in and run instead of your own, you can do that. And then args is those positional parameters that gets passed down into the container when it runs. You'll notice that these match the names of the inputs that we have defined above: database name, branch name, org name, from. And this is a truncated version of the actual action that's public out there right now, which we're going to get a little deeper into here a little bit. We have a Docker file. I said that this action points to a Docker file in the repository, so this is part of that repository. We're pulling from a base image, we're pulling a bunch of dependencies in, and then finally we have a shell file that we're running at the end of it as our entry point so we can handle those inputs and issue the right commands up into our CLI to create the branch for you. If you are publishing it out into the GitHub Actions marketplace, you need a README. The more examples you have, the better the README can be. The more people are likely going to use your thing. If you're doing something internally, it doesn't really matter, although in my opinion, it's still a good idea to have a README. How Docker Actions run. So I mentioned earlier, these things run on virtual machines. So when a job starts to execute, GitHub will allocate a virtual machine, and there are 3, to my knowledge, current supported operating systems inside of GitHub Actions. There is Ubuntu, there's Windows, or there's Mac. The reason they give you different options is because sometimes the projects you're building can only be built on certain environments. Mac is most famously if you want to build something for an iPhone or build something for a Mac, it needs to be run on a Mac for reasons I can't understand and don't agree with, but that's neither here nor there. So once your virtual machine is allocated, in this pretend scenario, we have 3 actions on the right-hand side that are going to be pulled inside of this virtual machine. Before the actual workflow or the job starts to execute, GitHub will pull in each one of these definitions and build them as containers inside of the virtual machine. You have very little control over the environment here unless you have your own agent installed on a machine in your own infrastructure. Once all of the containers are brought in and built, and once all of the definitions are brought in and built, the images are built, containers are then executed sequentially, the arguments are passed in, and you're basically running whatever code you have defined inside of the container at that time. All right, moving on to inputs. This is the untruncated version of that same action. We're going to focus in on these args down here. So this is the underlying entry point.sh file that executes on this inside of this container once it's run. You'll notice that for those of you unfamiliar with the shell syntax, $1, $2, et cetera, map to the arguments that are passed into the container at that specific point in time. So if you look, database name maps to $1, branch name maps to $2, and org name maps to $3. So at the end of this, once that command is completely instructed, the string is constructed at least, it'll be pscale, branch, create, recipes, db, dev, and in my organization it'll be Morrison PS. And if I don't provide a from, this is why we have to account for empty strings, because if from is not provided, we don't want to tack on the from to the command, so we can make decisions based on what parameters are passed in and what values are provided. And to further reinforce my point that this is how they're run, this is the output of the logs from one of the jobs that I had run. You'll notice in the blue text there, there is a bunch of stuff that GitHub passes into the container when it runs as environment variables to kind of support the environment that it's in. But if we look down at the bottom here, this D78, et cetera, :349 is actually the image that was eventually built on this virtual machine and will be executed. And then after that, these are my parameters that are passed in. So calendar DB in this case, calendar DB is my database name, dev is the branch I want to create, Morrison PS my organization, main is the branch I want to use as the base. But you'll also notice at the end of that I have 2 empty strings and then true, true. Just further reinforcing that you definitely have to accommodate for the fact that you might not get the value you're expecting in here, but it will be passed regardless. Actions also have outputs. Again, this whole idea of chaining things together to get the desired output for whatever your workflow is trying to do. We're going to look at the same workflow that I presented at the beginning of this talk. However, we're going to zoom into a different section here. The reason we're doing this is because when you create a branch inside of Planetscale, there's not a whole lot of useful output that comes out of it. But it is technically an isolated MySQL cluster in our infrastructure, so you need a separate connection string for that. That's what this action does here. So this will create a username, password, and a host name that you can use to connect into that separate branch. I'm not advocating for echoing out a password in the logs for whatever you're running, but it kind of gets the point across, so we're just going to roll with it. Now here is the ID for create branch password, and I noticed the error in my slide here. So the ID for this step is create branch password. Down at the bottom, we're echoing out, this is one of those inline shell steps looks like. We're echoing out steps dot. We're going to pretend that says create branch password again for the argument of this talk, but that is technically that second value there maps to the ID of the previous step. So we have steps.create password, create branch password, .outputs.hostname or username or password. The idea being here is you'd create this and pipe it up to a KMS service of some kind, not log it out, so you can actually connect to this thing. This is what it looks like in our action.yaml file. And again, just reminding, the action.yaml is stored in the repository where the action is. It's very similar to the inputs. You give it a key, in this case username, and then a description. So if you're using the IntelliSense as part of the GitHub editor, This is what kind of tells the whole environment that, hey, you can expect these outputs to be sent down the chain at some point. And then this, at least in the shell file, is how we would set those. So I'm parsing out the username, password, and hostname from that, and I'm assigning them to, I'm passing them, I guess piping them, I think is the right term here, to this GitHub output variable here that's passed in the container. This will execute a backend function that is higher than, I guess, the container. I don't know a great way of describing this, but it essentially executes a built-in function that will then save that output for later use. All right, small demo. Let's look at what an action looks like written in Go. I've shown you what it looks like written in with a bash script. Let's look at what this thing looks like written in Go. So this is a repository that's public in an organization that I have created called brianmmm-that-actions. Inside of this action repository, we're first going to look at this main.go file. And you don't need to know Go to follow along. This is pretty straightforward. It wouldn't be a simple example if it wasn't hello world, so we're going to run with that assumption here. So I have a main entry point function on line 8 starting. I have on line 9, we're pulling out the arguments that are being passed in, which are those positional parameters to the container. We're first checking to make sure that that value exists inside of the arguments, the name that we want to pass in here, which you'll see in a moment. And if it exists, we're going to echo out hello whoever, and if not, hello world. Backing up from here, we're going to take a look at the Docker file. So this is being built from the latest public version of the Golang image. We're setting up a work directory, pulling in the Go files, and building it into, I specifically want to call this action-bin. We're going to see this several times throughout the course of this talk. So this is going to build a single executable named action-bin. We're going to put this in a place that the entire container has access to, which is usr/bin/action-bin. And then we're also going to set that as the entry point. So this way, when those parameters come in, they're going to be passed into the executable that I'm creating here. Let's see. And lastly here, I want to show this action. So the name of this is that public action, not this one. We have a branding section here, which has an icon of activity, color of blue, a single input of name that is required, and then we're going to pass that down into our Docker file that we're creating. Now I also have this public workflow repository here, which just has a sample workflow that's going to call this thing. So inside I have a YAML file named hello workflow. The name is hello workflow because I'm extremely creative. On line 3 is where that trigger is, and I've set the trigger to workflow dispatch. Now workflow dispatch is just a fancy keyword that tells GitHub, you need to click the button to run this. It's not going to do anything automatically for me. So maybe that's something that's desired. It is in my case. We have a single job here named say hello that's going to run on Ubuntu latest. And then finally, we have the step here that's calling in that public repository and executing it to say hello to Clark. So once this is all run, you could say hello to Clark from anywhere in the world using GitHub Actions. Let's go ahead and go to our Actions tab and go to Hello Workflow. And we're going to run this just to test it. GitHub does a really good job of refreshing most of its UI automatically. This is one page where it doesn't, though, so I'm going to refresh it and go into here. Here's our job of say hello. Then here is the container being built right now. We'll eventually see some of our commands being run down below that are defined inside of our Docker file. There's that right there, building the code. And fingers crossed. If this demo doesn't work, I'm doing something seriously wrong because I think this is the most straightforward demo I could have possibly thought of. There we go. Had me a little worried there. So this is the same thing that we saw earlier. We have this giant chunk of blue text with all these environment variables passed in. I'm going to refresh this because the logs for some reason change after they've been run. And then we can see Clark is that parameter that's being passed into my container there all the way at the bottom. So we can say hello to Clark. Okay, so that's just a very, very straightforward, simple example, just to demonstrate that you can write actions in something other than shell scripts if you wanted to build them inside of Docker. Use any language you want. Next up, instead of showing you additional languages and ways that you could build actions, I figured it would be more useful to show you how you can use actions in a private way to build them and run them inside of your organization. Everything in the marketplace is completely public and open access. In order for an action to be published in the marketplace, it needs to be in a public repository. but sometimes you want to build these actions to use privately. You don't want to publish them. So I'm going to show you a couple scenarios and ways that you can use that. The first thing to understand is whenever these things run, they run with the security posture, I guess, of the repository that holds the workflow. So in our example case here, we have a workflow that is inside of a private repository calling an action that is inside of a public repository. You're not going to run into any issues here because the action's public and anyone can access it. Anyone can access the source code of it. Things get a little trickier when you want to use a private action though. Because the repository with the action is locked down, even if it's within the same organization by default, trying to execute this will actually fail. Has anyone ever who works in a GitHub environment tried to access one of your organization repos and might not quite be logged in at the time you try and do it, and you get that big octopus 404 thingy? Well, the same thing happens to GitHub Actions whenever the workflow tries to execute. So the trick around this is inside of the repository for the action, if you navigate to the settings of that repository, and then you go to the left-hand side here, there is a section here for actions. We'll go to we'll go to the general section, a general option there. And then all the way down at the bottom of this page, there is a section here named access. And there is, by default, not accessible will be checked. In this case, I had already changed it. But this option here, accessible from repositories inside of my organization. This will make the action be accessible to any private repository that is in my Brian Dev that actions organization. And once we do that, we can see that this thing will work no problem. Now, the next one I want to go over, which is really cool, is using a private base image. So if you recall earlier when I was walking through the way that these things ran, you don't have a whole lot of access over the build environment. So in this scenario, what we're going to do to embed some private build stuff inside of a container is we can create a container that gets published up to some kind of registry, which will then be utilized by the runner that executes that specific job. This is my diagram from earlier. We're going to rewind all this and forget and go before anything was ever built. So what happens when you define a base image is when the job first starts, before it starts building and creating any of the images it needs to execute any of these steps, it will actually pull in your image and then wrap the entire context of the job inside of that. Meaning if you have any kind of tools that you want to pass into your containers at that point, or I guess run through shell scripts, you can do that by using this approach. Once that main base container is built and everything gets run inside of it, at that point then your actions get pulled in and then they get executed and then everybody's happy. So to demonstrate this, I'm not sure how popular this is, but GitHub does have a feature called GitHub Packages, which does allow you to publish Docker images up into it to store it along with your organization so you can kind of keep your code and your images in one spot. You don't need to go find, either use the Docker Hub registry if you want to, or you find some other registry to do so. So in this example, I'm going to use this GHCR base image package that I have here. I had another demo that didn't quite make the cut, so we're going to pretend, again, that one doesn't exist there. Clicking inside of this base image, I have a URL of ghcr.io / my org name / the image name, which is GHCR base image, latest, which is the tag that I have published here. And this is what we're going to pull in to our environment. So just going through what the code for this looks like, the hello world code is exactly the same as I showed in my manual demo, with the exception of I prepend the log file with this from GHCR just to show you that it is indeed a little bit different. Backing up from here, looking at the Docker file, this is going to be exactly the same thing that I had shown earlier. We're building that action bin executable, and then we're going to set that as the entry point. So great, we've got our image, we've got it pushed up to the registry. However, again, everything runs with the security posture of the repository that is executing the workflow. So if we don't explicitly allow access to the image in this case, it's going to fail again. And I'm going to show you how to fix that. So go to the Packages tab and select the image which you want to use for your base image. There is a package settings on the right-hand side. If you select that, there is this option here to add repository. And this will allow action-specific repositories to be able to connect to the GitHub container registry for that specific image and pull it down and execute it. This is what the workflow looks like when using a base container. So we have a new container object that's added underneath the runs on. We have our image being specified here of this GHCR base image. That's the URL we saw earlier. And then I'm using a special set of credentials here called github.actor and secrets.github_token. These are actually special variables that are available when you're running actions that loosely map to the username and password for the actual repository. Because we changed the security settings of our image, allowing our repository to access it, you don't have to create a custom like GitHub personal access token in order to do this. You can use these two variables. And then on the bottom, the only step I have running here is we're going to call our action-bin, just demonstrating that this executable is indeed available to the steps beneath it. And then I'm passing in my own name. And there we go. So that now works. All right, now let's talk about testing your actions. Some people think that you might have to push actions up into it and create a workflow to test things. That's not always necessarily the case. Because we're building Docker actions, we can simply build an image on our machine and run the container. So this is a makefile that just has a simple test script in it. It's running Docker build. I'm tagging my image just so this way I can reference it. And then I'm running Docker run with the name of my image that I just created locally and then a name to test it. And it works just the same as if it would inside of GitHub. The next thing is using Git refs. So I had mentioned earlier that you can use Git refs to find specific versions of your action. So this is what we had seen earlier. I'm using planetscale/create_actions at v1. That is the v1 tag that I have defined inside of the repository. Next up, I have create branch action at main, which would pull in the latest version of the main branch. I could use the dev branch if I wanted to, or if I wanted to get crazy specific, I can actually pull in a single individual commit hash. So if you want to find a very specific version of your action and test it out, maybe something started failing and you want to go back and test it out before that to see if an earlier version of your code did work, you can use that approach. Finally, you can automate it. If you want to get really crazy, you can actually build a workflow that exists inside the repository with your action to recursively call that action and build it every single time you publish it. Really, your imagination is kind of the limit here when doing some of these things. So let's wrap up. I'm actually going to backtrack a little bit because I just now realized I missed an actual part of my demo I wanted to show off. So I had thought about putting a section in here about how to publish a GitHub action to the marketplace. But I figured, why the hell not just do it in front of everybody? So this is the public action repository that we looked at earlier. The way that you would publish an action out to the marketplace is by just creating a release. And because GitHub is smart enough to know that this repository has the source code for an action, you'll get this checkbox above here that says, publish this action to the GitHub marketplace. So I'll go ahead and check that. It's going to run through and run my repository through some checks to make sure I have all the necessary elements to publish it out. You have the option here to select a number of different categories that you want to publish it to help people find your action in the marketplace. And then we're going to go ahead and create a tag here. So I'm just going to say v1. We'll create a tag of v1 and generate release notes because I'm extremely lazy. And let's go ahead and go down here and publish this. And don't steal my one-time token that's only available for the hopefully next 30 seconds. And now that we've published this thing out, you'll notice that even on my release, I have a new tag next to the name of my tag, named Marketplace. So if I click on Marketplace, this action is now publicly available for anyone on GitHub to come in and use. So now, again, you too can come and say hello to Clark whenever you want to.
Finally.
I know, right? All right. All right. Now we get to the wrapping up section. Final tips. Make an action do one thing well. There is this whole concept where you can create some kind of super action that does 5,000 things and you just shove it all into one repository. I'm a big fan of the whole single responsibility thing where you write your code to do one thing and do it well. But again, choice is yours. Set good defaults. An example I want to set here is, recall earlier I had said when you're defining your parameters, you can make them optional or not, but you're still going to get something passed through, even if it's in the sense of an empty string. Think like the people or the users that are going to be using your action when you're defining the defaults for your workflow or for your action, I mean. An example of this is going back to, again, the PlanetScale create branch action. By default, when you create a branch, typically you want to wait for that thing to be created, because our CLI will just say, hey, we got your message, we're going to go ahead and create that branch. But it takes a little while to spin up that infrastructure and get everything ready to go for you. So by default, we'll sit there and we'll wait for that branch to finish being created before we'll move on to the next part of the section, or next part of the workflow. You can optionally opt out of that if you want. If you just want to create a branch in our service and say, you know what, I'm good to go, all I need to know is you got the message, we give you the option to do that, but we don't think it's a good default. You should make actions repeatable. Don't make an action that returns different results based on the time of the day, for instance. You want your things to be really consistent so people can use them and trust them. If you're publishing it to the marketplace, or if you're a developer, create a good README. I think READMEs are extremely important, especially for repositories that are shared amongst multiple people. So fill in good descriptions, put a lot of good examples in there, define all your inputs and outputs, say what's required, say what the default behaviors of each of your things will do. Make it as easy as possible for people to be able to use your action if they find it in the marketplace or within your organization. Finally, this is inspired by personal experience, which catches me all the time. Build for the runner platform. So I demonstrated that you can build an image and push it up to a registry to be able to pull in for your thing, right? Good chunk of developers like Macs. They're nice and shiny and they do things really well and quick. But they're also running a completely different processor than something like Ubuntu is running most of the time, where it's got an x86 architecture. This thing has an M1 architecture. If I build an image on here and I push it up to GitHub Container Registry and then I try and use that on a Ubuntu runner, it's going to fail because I didn't build it for the x86 architecture. So that's a pro tip that will save you a lot of stress in pulling your hair out. And then finally, an experiment and have fun. At the end of the day, these are just small functions that do things in a really, really cool way, in my opinion. But again, the sky's kind of the limit with however far your imagination can take you. So play with it, find out what works for you, find out what people in your organization enjoy, like to work with, and have fun. Finally, this is a link to the actual homepage of the organization that I created. If you're not into scanning QR codes, the direct link is down there below, github.com/BrianMMDev-that-actions. And there's a bunch of different resources that I've kind of put in there to get you started. First off, it's everything in the organization, even though I've demonstrated private things here. It's all publicly accessible, so anyone can go in there and examine the source code and figure out how some of this stuff works. I also have a couple of examples that didn't make it in there. There is one that shows you how to build a container using NPM and JavaScript, if that's more up your alley. I have one in there that's a simple creating with Bash, and there's a couple other that don't quite come to mind right now. I also have links to the plan scale actions that I showed off here today. Not all of them, but at least the ones that were pertinent to these demos. I have links to the workflow syntax documentation. We touched on a decent chunk of what's available inside of workflows and inside of the action.yaml, but there is some stuff that I couldn't realistically cover in this 1 hour talk, which is clocking in at 40 minutes right now. So definitely go there and take a look and see if there's any different options available to you when you're building your actions. Next up, Sarah Drasner, who's pretty well known in the tech ecosystem or space, she has a repository named Awesome Actions, which I actually agree with is pretty awesome. It is a giant collection of different demos and ways that actions have been built. There's just tons of stuff in there, more than I can even describe here. But if you're looking for inspiration or want examples on how you can potentially build actions, that is an excellent repository to go look at. And then finally, as of right now, the screenshots for all of my slides as well as the video chunks are all published up inside of a repository there as well. So if you're interested in recapping this, there's that. I am also recording this, so once I get this thing produced and out on my YouTube channel, it will be linked there as well if you want to check it out afterwards. Thank you for my time. That's my contact information. And if anybody has any questions, I know I talk very fast, so happy to answer them if I can.